Hello, welcome to our video helping you with your shape homework this week. This question here says draw an isosceles triangle. And obviously you need to remember what an isosceles triangle is. If you can't quite remember, then you can maybe try and think about the other types of triangles that you do know. So we know a right angle triangle's got a right angle in it. An equilateral triangle has all equal sides. A scalene triangle has got all different sides. And an isosceles triangle has got two sides the same length. My top tip for drawing an isosceles triangle is to keep the bottom straight along a line like this. And to keep both sides the same length, you need to make sure that you have got a middle point. So you need to have an even number of squares along the bottom. So it might be 2, might be 4, might be 6, but it needs to be even so you can have that middle point. So if I show you down here, if you did it with 3, you haven't got a middle point. That here or here isn't the middle. If I extend it and have one of 4, then I've got a middle point here. All I do is count up from there. Any point along this line I can choose for my other corner of my triangle, and when I join those lines up it will be an isosceles triangle. Mine's not very neat, but hopefully you'll be able to use a ruler. I'll show you another one, so I might do this one a bit longer. I've done it, so I've still got a middle point. I count up from there. That is still an isosceles triangle. These two sides will be the same length. On this next question, we've got a cowl diagram. Everything in this row has this property here. So everything in this row is a rectangle. Everything in this row is not a rectangle. Here has at least one right angle. And anything in this column has no right angles. Well, the best way to check for a right angle is to use something that you know has got them. Something like a square, the corner of a piece of paper, corner of a ruler. And if we pop that into the corner, if it fits exactly, then it's got a right angle. So I know this shape here has got at least one right angle. If I do the same to this one, now that doesn't fit in exactly because that shape disappears down the back of my shape. If I do it in this corner here, I can see that the angle pops out the other side. So this one, at the moment, after looking at the first two angles, it looks like it does not have right angles, but we need to check this one and this one. Sometimes you get shapes and they look very, very much like they don't have a right angle. When you look at it, they actually do. So my top tip would be, use something like this to put into the corners, and don't be afraid as well to just rotate your sheet as well. Sometimes that makes it a little bit easier to see those tricky ones that look like right angles, but actually they turn out not to be. Now the next thing you've got to do is know the name of these shapes. We should know some of them more than other ones. If you're not quite sure, there are some links on the website that tell you the different names of shapes. Obviously they're all quadrilaterals, but we can't put quadrilateral in each one. That wouldn't really help us. To start off with, if you don't know the names of the shapes, you could always just give them a letter, A, B, C, D, and that would be a start. You can put them at least into the diagram, even if you don't know what they're called. This question is about reflecting the shaded shape. Now, these questions are often quite tricky, even though they look really simple, quite easy to get wrong if we're not careful. The best way I've found to do it is simply count from the mirror line. So we've got our mirror line down here. If we count out from the mirror line one square, we know this square here should be shaded in. So I'm going to shade that square in. It doesn't have to be particularly neat. There we go. I've done this square here, so now I need to reflect this square. This square is 2 squares away from the mirror line, so I count 2 squares out and shade that one. This one here is 3 squares out, so I go 1, 2, 3 squares out and shade this one. This shape here is 1, 2 squares out from the mirror line, so I go 1, 2 squares out from the mirror line on the other side and shade it in, and so on. If I complete that, I should have a perfect reflection of the shape on the other side. It doesn't matter if there's the odd little dot here or there, that just shows you're working out, and so on. Now this is where the counting trick comes in really useful, when we've got a mirror line that isn't straight. Well, it's straight but it's diagonal. Okay, so it's not horizontal vertical, it's a diagonal line. So it can be quite tricky to do, but if we follow the same technique, especially the technique we talked about on the other page, where we just rotate either this way, or you can rotate your page that way, just makes it a little bit easier to see sometimes. So now I'm going to do the same thing, so it's 1 square that side, so I'm going to do 1 square the other side. I'm going to shade this one in. I put a little dot there so I know I've done it. Then I go up to this row here, I've got half a square, and then my shaded square. So I count the other way, half a square, and then my shaded square. Go up to the next bit, I've got a full square, then my shaded square, so I do a full square on the other side, and then my shaded square. I haven't got any more above that, so I go back down here. I've got this square here, which is 1 square and a half from the middle, so half a square, 1 square, and shade this one in. This one here is half and 1 and a half, 2 and a half. It's the third one, full square on. So I've got half, 1 and a half, 2 and a half, and the third square one will be 3.5 squares away, and so on. Okay, so this one is a half, and then it's the next full square, half, and then the next full square, and then it's the next one shaded in. So I've got full square, shade the next one in, and then this last one it's half and 1, and then it's shaded in. So half and 1, and then it's shaded in, and I should have a perfectly symmetrical version of the shape on the other side. I hope that's helped.